Okay, it looks like we're live. Welcome back. Today we're going to be doing some more OCaml. Basically, we're going to be solving these 99 problems. Not all of them today, but I'm going to start working through some of them. Before that, so I've been learning it. I'm still pretty new to it. I started a couple days ago. I streamed that. It's completely different. So it's not something that I can just pick up and learn because I've never used a functional language before. So it's something completely new. Something that has helped a lot though is this. It's like by Michael Ryan Clarkson. He works at a university or whatever. I will leave that in the chat. It was very useful. Explained things really well. Some things were a little confusing in there, but overall, I would recommend it if you want to learn OCaml and you have no experience with functional programming. Yeah. So without further ado, let's get into it. So let's see. I think I'll just make a different directory for each problem. So this is problem 1. So let's see. So what do we need to do? Write a function that returns the last element of a list. Okay. So that should be pretty easy. So yeah, alright. Actually we'll call it last. And it takes a list. Alright. Actually we can do this. Function. Alright. So let's see. So there's gonna be a couple different things. So if it's an empty list, then we want to return none. Yeah. If it is a single element, then we want to return some x. Yeah, that looks right. And then let's see. And then otherwise, then we'll do this, and we'll return last tail. Yeah, and then you don't need to do this, but I like it better putting the double semicolon. Yeah, so I think that will work. So if we actually open Utah, and then we use main.ml, there we go. Okay, have to declare it as recursive. I forgot to do that. That is rather important. Okay, so now if we pass in an empty list, have to put the double. There we go. And if we single element, sum 1, sum 2. Alright, and let's just add a bunch of stuff. And that's gonna mess up. 5. And sum 5. Alright, so that worked. So we are actually done with that now. Yeah. So I can actually exit out of this. And exit out of this. Alright, and I will actually go ahead and commit that now. So let's see. Solution for first problem, tail of a list. Alright, so that was pretty easy. They do get progressively more difficult, of course. So I can actually push that. Okay. Oh, yes. There we go. Alright, there we go. So I push that there. So I can actually go ahead. Here is the GitHub repo where you can view all of our solutions. Yes, indeed. So now let's make problem 02. Yep, that looks good. Okay, so main.ml. Last 2 elements of a list. So that's a little different, but not too different. So gonna start out the same way. Where we have let's see, last 2 equal, we're only having 1 value, so that's all good. So if it's an empty list, we return none. And then if it's a single one, then we return none as well. Alright. And then if we have just 2, so I think we do it like that, then we return some x and y. Otherwise, we have to do this kind of thing. And then last 2, tail. Yeah, actually we don't need this value, so I can go ahead and do that. Yeah, alright, and we have set it as recursive. So now if we open up Utah, I can do stuff, right? Alright, main.ml. Alright, and if we get the last 2 of this, it should be none. Alright, and then none. some 1, 2, and then 2, 3. All right, so that seems to be working. So once again, that was pretty easy. Yeah. So let me actually commit that now. Solution for problem 2, last 2 elements of a list. Okay, and we'll push that. There we go. So now that is up. Yes, indeed. So if I quit out of there. All right. Problem 03. All right. Yeah. So let's see. May not know. All right. So let's take a look. Nth element of a list. So all right. Yes, indeed. So let's look at that. All right. Let's let. It's gonna be recursive. N. All right, so we need 2 values on this one, so it's a little different. List and the nth equals match list with. All right, let's see. If it is that, then we return none. All right. So let me think about how to do this. So we need to check. So we do that if n equals 0, then x, some x, is that what it wants us to return? No. Alright, so it wants to just return x. Else, I forget how to do this. Exception. Failure. Alright, I don't know if that'll work, but otherwise we have to do this and tail, and we'll do this nth and then n minus 1. Okay, so let's see. I'm not quite sure that'll work. Let's see. Main. There we go. Alright, so that doesn't work. So I think we actually have to do something like that. Alright, how do you... Let me look at exceptions. Exceptions in OCaml. Let's take a look. Alright. Alright, you have to do raise. Does that work? Uh-huh. Alright, so now that... Let's take a look at this. Alright, well let's just return 0 for now, and then we'll get the exceptions working once we are sure that this works. Alright, A option. Alright, whoops, let's see. I actually did this in the wrong order. Okay. Alright, so let's try... Alright, expression that has type int. Alright, yeah, so that is the problem. So let's actually do... This should be a list of ints. Oh, okay, it's because of this. So this actually wanted to return 0. Then we can change this to 0. Alright, and let's see. Alright, and it gets stuck in an infinite loop. So, if n equals 0, then so that's not quite right. Let's see. this should be tail. Alright, nth of 1, 2, 0. Alright, yeah. Alright, so that's not quite right. So what is the issue that we have here? Let's see, nth tail. Right, actually, this isn't the right order that we want to be doing this. So, actually, let's see. So I think we can get rid of this one. And we can change this. So we can do if, let's see, if, we're going to need this value. If n equals 0, then head, else we'll do n of tail and n minus 1. Alright, 2, 1, 0. Alright, then if we do -1, then that doesn't work. Okay, 5, and then it just turns 0. Okay. So yeah, if it is out of bounds, then we want to raise an exception. So, alright, so we need to do something like raise exception failure, something like that. Alright, let's see. Alright, actually I think we can just raise failure, right? Alright, let's see. Alright, let's try to actually read this. So, alright, let's see. How to raise exception in the OCaml code. Alright, so it doesn't like that. So what if we... let's see. Then... Alright, so that doesn't work. Hang on. Let's see. OCaml raise exception in match. Do I need to do that actually after? No. I will do that though. Let's see. Yeah, that's not... So yeah, I do like that it shows you. Here's an example of a case that is not matched. That is very nice. Yeah. Problem is, I don't know how to make it work. I can return 0, but that's not what it wants us to do. Right, because in here it shows exception failure nth. So exception failure nth. Yeah, it doesn't work. Let's see, so we want to expect, how do we do this actually? OCaml exceptions. Alright, raise failure food. So why doesn't that work when I try to do that? Failure food. Oh. Okay, so let's see then. Nth 1, 2, 3, 0. 1, 2, 3. Alright, there we go. Yeah. So I don't know how do you get it to print this message though, because I would like it to say that. Alright, oh, you have to wrap it up, right? Nope, that's not right. Why does that work here though? Yeah. I think that's good enough for raising a failure exception. So then we can get n. Let's see. So if it's an empty list. Oh yeah, we didn't actually return it. There. Yeah, we get a failure because there's nothing in the list. Yeah. Alright, so that is good. So I would say that that works then. Yeah, so there's nothing I can think of to make that much better. So we can actually go ahead and commit that. Added solution for third problem, nth element of a list. Git push. Alright, and there we go. Now it is up on the GitHub. Right here. Yeah. Just want to make sure. Alright, so it all seems to be working. Yeah, alright, so that's good. So let's go on to problem number 4. Alright, so let's see, what is that? Length of a list. Alright. Tail recursive solution. So I was looking a little bit into that. Yeah, we'll solve it regular right now. Yes. Alright, so let's try that. Let's see, we're already in there, so let's vim main.ml. So let's see. Length of a list. Yeah. So we just need one parameter, right? So we'll let length equal function. Alright, let's see. So what are we gonna match it with? Let's see. So if it is empty, between 0. Otherwise, do that, and then return 1 plus length of tail. So I don't think we need the head actually. But if it's just 1, then we can return 1. Yeah, and this is actually going to be recursive. So let's actually try that. I think that should be it. In that ML. Alright, and let's get the length of that. Oops. 0. Okay. 1, 2, 3, 4, 5. Okay. That seems to be working. Now let's look at this tail recursive. So I watched the Tesoding, I can't pronounce words, but his video, he actually went into detail about this. I'm not sure I fully understand it, but I think basically what it is passing it as a parameter rather than doing it like this, where it has to keep track of that and you can get like Stack Overflow and stuff like that. Let's see. But that could be completely wrong. Yeah. Let's see if there's something tail recursion. Let's see if we can find a better resource for it. Okay, let's see. As the who is that? That's what it would evaluate. Yeah. So that's basically what ours is doing right now. Every recursive call has to complete before the. All right. Here's. Yeah. So you pass it as a parameter, and then you can keep track of it better. Yeah. Alright, so let's actually try that. That should be pretty easy. So let's do let recursive length tail equal, actually, so we need a list and we need the n, which is just the current value, right? We'll match list with that, then we'll return n. This will return 1. Actually, I think we can do that. And then here we do that, and then tail, and we'll return length tail list, and then n plus 1. And I think we need to do that actually. Alright, let's try that now. Alright, length tail, that. Oh yeah, and we need to add the extra parameter. So 0. And it always starts at 0. There might be a way to set default parameters though, now that I'm thinking about it. Alright, 1, and then it's always 1. Okay. So that's not too good. Alright, So let's see actually. N plus 1. I like to separate that actually. So that should be incrementing it by 1. And now it gets stuck in an infinite loop. That's not very good. Alright, let's actually, we can do this trace thing. Alright, and now when we run it, yeah, it shows everything that it's doing. Rather interesting. Alright, let's see. Alright, so we never have like a break, right? I think that is basically. So let's think about how it is calling it. So here we're calling length of tail again. This is a problem. We need to pass tail. Okay, yeah. I'm just stupid. Okay. So that worked. 3, 2, 1, 0. Okay, and I think, yeah, it's good doing it this way because then it's we pass in 0 as the initial index. Yeah, alright, so that's good. Alright, so now I think we can do that trace thing again. Length tail. Alright, whoops. I need to do that actually. Alright, and now we can call it, and this is everything that it is doing. Alright, and then, well, hang on, let's trace, length. There we go. And let's see the regular length function. Alright, yeah. Let me open up a new terminal. There we go. This is problem number 4. So let me actually open UTOP in here. And then we will trace, length. Whoops. And we will trace tail length. Alright, so now it's called length. 1, 2, 3. Shoot. Oh, yeah. I forgot to use it. That's my bad. Alright, now we can trace it. Unbound bound. Alright, now let's trace length. Alright, and then length tail. Alright, and now it's called length. And there we go. Let's actually do it on something a little bigger. 5, 6, 7, 8. Alright, and we can see that. Length tail. So let's see. There we go. And yeah, you can see it is much less. Because it's not using as much of the stack. Because it's just passing the parameter. Okay. So that's pretty good, I think. So let's actually exit out of this now. And let's go ahead and commit that. Added solution for problem 4, which was called what? Length of a list. A list with tail recursive solution. I think. Not entirely sure still, but pretty sure. And there we go. Just push that. So now, problem 5. Alright, and let's see. So let's actually open that. So let's look at problem 5. Reverse a list. Alright, so this is pretty interesting. So lists, I can actually look that up. I think I can go in here. Let's actually search for lists. And if I could spell. So lengths, or lists in, no, I don't want packages. No, hang on. OCaml list implementation. So let's see if I can find something on this list. Is this kind of what I want? Yeah, this is sort of what we were talking about before. Tail recursive uses constant stack space, while a non-tail recursive function uses stack space proportional to the length of the list argument, which can be a problem with very long lists. Yeah. Alright. Yeah, 10,000. So let's take a look here. I want to see like the implementation of it. Alright, well basically, it's a singly linked list, right? If we actually look that up, singly linked list, we can look at what that looks like. Yeah, geeks for geeks. Let's see what they have in here. So here it is. You have the root node, and it has some data, and then it has the next, a pointer to the next one. And there you go. And it points all the way. And the last one, there's that. Last one points to null. Yeah, a doubly linked list, it like wraps around and stuff. But yeah, so this is that. So we can actually look at reverse a linked list, check out the implementations of this, and we can kind of implement a similar idea in OCaml, because that's what it is a linked list. I'm gonna look at Python just because that's pretty easy to understand. Alright, so we have like a node here. Yeah. Previous. Alright, actually, do they just have a description of how they do it? Yeah. Alright, so what you do is you set the next one equal to the next of the current node. That's pretty self-explanatory. then you set the next one of that equal to the previous, and then the previous equals the current, and then the current equals next. So that sounds kind of confusing, but it makes a lot of sense. I could actually illustrate that for you, if you'll allow me to. So say you have, this is your list, right? You have a couple of nodes in here. So say this is 7, this is 8, and this is 9. Alright, and then this is the starting element, and you want to reverse it so that it is correct. So what you would do, starting on this one, get the next one, and you set the current equal to the next one, right? So then this is now the current one. So 8 is the current. I'm trying to think about how to keep track of this because it's confusing to explain. Yeah. And then you want the previous to be equal to the value of that one. And then you want this to be 9 actually, and this to be 8. And then you can do the same thing for the next one. I'm not sure if let me see, I'm not explaining that right. I'll just sort of implement it and show you. Alright, so we can do something like let reverse equal function. Alright, so let's see. So how do we want to do this? If it's that, we can just return that. If it is a single element, we can just return that single element. Otherwise, head tail. Then we're going to return, let's see, this is actually going to be recursive. So we can return, let's see, we can return rev tail, and then we can append head. And I think that's all that we have to do. So let's see. Alright, I actually messed something up here. I want to do something like this. Alright, oh yeah. We need to actually make that a list, because that's what it's expecting. Alright, there we go. So now if we reverse an empty list, it returns an empty list. A single element, it returns that. And now, there we go. 2. We say this took 3, 4, 5, 6, 7. And there we go. So it successfully reverses it. So basically, what this is doing, we have the head and the tail, and we're setting the head equal to the last element, right? So then we can actually trace this and see it pretty good. Yeah. So this is all that I need doing here. So let's actually do this. And we will use main.ml. And we'll trace rev. Whoops, I gotta do hashtag trace rev. And then, alright, so we can look at what it does with that. Alright, so it just has that, goes through it once, and it does that. Single one, same thing. Can't really see the items very well. Forget how to fix that. But you can sort of see how it's working. Yeah, because it starts out with this, and then it shrinks, but it appends that to the end of it. Yeah. So that's basically the implementation of it. We can actually look at the solution and see if that's what's intended. So not exactly. Yeah. So that's a little bit different. So I don't... Yeah, this is like a nested function. I feel like mine is a bit simpler. But it's probably not as optimized, so... But yeah, there we go. I'm gonna say that's a successful solution. So I will just go ahead and commit that. Added solution for 5th problem, reverse a list. And there we go. So we can push that. And there we go. And let's see. My internet is dying. The stream might die as well. Hopefully not, but it could happen. Alright, yeah. So it seems to have worked though. Alright, so now let's do problem 6. So what is that? Palindrome. Alright, so actually we do need to use the previous problem for that. Well actually we'll just use the list.reverse because we did use that one. And I think that's fine. Rather than copying and pasting and all that stuff. So yeah, so let's is palindrome equal to let me take a list actually. List and list 2. No, we don't need list 2. So yeah, we can actually just do this. Yeah, we'll do that. Okay, so let's do if list.reverse of list equals list, then true, else false. I think that'll work actually. Let's do Utah and use main.ml. Alright, so let's check that. Is palindrome that one, let's see, true, and this should be false. There we go. And now that should be true. And then that should be false. And now let's actually reconstruct that. True and false. Alright, so that seems to be working. Perhaps I think I'll just do this again. So let's just make the reverse again. Just because I don't like using the library for it. Equals function. Alright, let's see. There we go. So let's see. What do we do here? So we return that. We return that. Otherwise, we do that. And we return, no, rev tail at head. Just like that, I think. And, whoops. And there we go. So we can add that. And we can just use our reverse instead of the built-in. So let's actually use that again. Alright, and let's check that now. Palindrome. Alright, so that seems to be working. So yeah, I like that better. But yeah, so that was not too difficult. Seems to have worked. So let's actually go ahead and commit that now. Let's see. Added solution for 6th problem is palindrome. Alright, we'll push that. Okay, so now we're on to problem number 7. Alright, so let's see what that is. Flatten a list. Yes, so I was looking through these. Not too sure on this one. Because it's just one of the things where it's like, if you're not used to OCaml yet entirely, then this looks extremely confusing, you know, because it has the one, many. So I'm going to work through it and see if we can figure it out. But I don't know, I might need to do more learning off stream before I can figure it out. So it's like a collection of lists. So let's see. So let's match. No, not match. Let flatten equal. Alright, let's see. So in the case of 1A, then return. How do you get the index of a 1? And return A like that. Let's see. Okay, so many. I'm not sure this is right. Yeah, so I'm not sure I'm doing this right. Let's see. Main.ml. Alright, unbound constructor 1. Alright, yeah, so let's actually look at like OCaml match many options. Alright, yeah, let's look if they have something for that. So something like many, 1, none. It's not what we want. Alright, let's see. Canonical way. I like the way that is put, kinda. Ooh, this is like fancy stuff. Doesn't look like what I want, right? Let's see, can I actually just, kind of take a look at this? If I go ahead and copy that, and I just paste it in there, with that. Alright, unbound constructor 1. Let's see, I might need to do that first. Alright, and now let's try that. Alright, so, string node list. Alright, let list equal. Alright, so now we can print the list. Yeah. So let's see. List dot. I forget how to get the first. Got in. List 1. Yeah, that doesn't work. Let's see. I'm not quite sure. Alright, let's try just using like regular list stuff. And return none x, return some x. And let's just kind of see what that looks like. So if we use a.ml, and then we kind of do that with the list. Alright, yeah, match failure. It's not what I want. It's just like complex pattern matching. That's basically what we're working with here. So you can match with strings, but that's not. So what happens if we do something like that? Alright, that doesn't work actually. Alright, now let's do flattening list. Alright, so then we get the first one. Alright, so this should cut the whole thing down. Alright, so that cut out the first element, it looks like. So, that's interesting. Flatten T. Yeah, that doesn't work. Yeah, that doesn't. So I'm just trying to figure this out. So I guess this is what we get when we. This seems to be recursive actually. Yeah, it doesn't change anything. So basically, it looks like this is one list, and then there's another list within that list, and then another list within that one. So I'm not sure how to work with that. Let's see. OCaml nested list, but it also has these one and many thing. Alright, wait, there's no, so we need to define one first. Yeah, that is on here, I think. No. Yeah, flatten a nested list structure. What does it say we need to? We need to nested list. Oh, that must be in the solution, probably. Let me look at that, actually. Yeah, so you're supposed to put that in there. Yeah. Alright, yeah. I didn't really read through that. I'll come back to that one. But we can do this one, I think, pretty easy. So, this one is on temporary suspension. Number 7. Let me just, temporarily suspended. And I'll just leave that there. Alright, problem 8. Because this one, I understand it a lot better. Problem 8, and we will main.ml. Alright. So this is what we want. Eliminate duplicates. So, compress equal. So what do we want to do? We want to check. Let's see. So if it is this, we can just return that. If it's 1, then we know that there's no duplicates. So we can return that. Otherwise, we've got the, I'll use H and T for consistency. So we have the head. We need to check if it is equal to the first element of, yeah, actually, let's make a function that does that. So let's do let first equal function. Actually, I need to do that here too. Equal function, and we'll match that with that, that with that, and then otherwise, then we'll return head. Yeah. Alright, so that's what we want. So then we can do first, actually we can do if first t, or actually if h equals first t, then let's see, then what do we want to do? Then we want to cut the head off. Then we'll do compress h. Yeah, no, compress t. Else, we want to leave the head on. So we can do, let's see, we can do something like that, I think. Let me actually close this one. Alright, so let me actually see. Use, if I can type, main.ml. Alright, oh yeah, so this we actually just want to return single elements. If it's none, we want to return none, but I think we can do that actually. Perhaps we can't. First. Alright, yeah, so we gotta do something like that, if that will work. Yes, that won't work actually. So then we'll just like raise failure, something like that. And then we can just return this. Actually, I'll make this H and T and H. There we go. Alright, so now if we do that, raise failure, empty raise. Alright, that doesn't work again. Shoot, I forgot what I did. Let me make a new tab. Go here. Can I go // That doesn't work. No. Alright, so let me close the tab. I'll open a new one. Projects. OCaml. 99. Alright, so that was in problem, was it 1? No, it was problem 2, right? Alright. I guess it was 1. Problem 2. Alright, raise failure. So that's all we had to do. then we get an issue here. Oh, I don't see why that works here. Let's copy that and see if something comes up. Let's see. Yeah, so that's not going to work, but yeah. So match value. Oh yeah, I need to do that actually. I don't quite understand what the difference is between these two. Does it not work in this style function? No, it still doesn't work. Do I need to specify that? No. It's not recursive, so I don't quite understand what the problem is with it. We can ask ChatGPT, if you will. Yeah, because I don't know. Like, I don't know what the difference would be. So I just copy that whole thing. Why does this OCaml code not work? Bam. Let's see what it says. Should work. Is it? However, there are a few things to note. Yeah, let's just take the error message. This is the error I get. There. Failure exception expects an argument. Alright, let's do that then. ChatGPT knows all. Failure. Oh my gosh. Actually it did work, okay. Yeah, so what is the error that we're raising? Match failure. Alright, so let's do first of that. Match failure. Yeah, okay. So that is 1, then 2, or then 1 on it. Yeah, so it's always going to be 1. So now, if we do compress, an empty list, then it just returns that. this returns that. That returns correctly. But if we do that, there we go. 2, 2, 2, 2. Yeah. And then we can go 3, and then it should remove this one because it's not consecutive. There we go. So that seems to be working. Let me just add this, make it look a little better. Let's see, could we make this better? Could not match. Or actually, we can just say empty list, I think. Empty list. It's probably a better error message. But yeah, so that seems to be working. Yes indeed. Okay. That's pretty good. Pretty good. It would have been a lot, would have figured out a lot faster if it wasn't just with the error stuff. But yeah, so that worked. Git add dot git commit dash n added solution for problem 8, I think. For problem 8, eliminate duplicates, and it does specifically say consecutive. Just so you know, just so you're aware. Okay. Yeah. And we'll make sure that went up. We don't need that anymore. And there we go. No issues, it would seem. Alright, so let's see. So now this next one. Let's see if we can figure this one out. So problem 9. Alright, so .ml. So it's very similar to the last one, but you want to pack them together. So yeah, so you need a nested list, which we did actually define up here, but it's not exactly like that. Let me actually try something. Let list equal, or let test equal test list equal, and then we'll just return that. And let's see what it says if we try to do that. Alright, so if we do test, alright, so that does work actually. So that might make things a little easier for us. So basically we want to do that, and we just want to return that. And if it is that, then we can return that. Otherwise, we can do a very similar thing to what we did before. So if let's see, so we need the first again. So let's see. Could we implement that? Yeah, I'll just do it really quick. Let first equal function. And then yeah, so that we will raise failure empty list. And then with this we can do that, and return head. There we go. And we'll do that. If I could type. Alright. And we'll do that there. If head equals first of t, then let's see. So we want this kind of thing. We want head. Let me try this. Head is t. Alright, we need to do that. I'm not sure. Else, we want to keep it. So what can we do to keep that? Else we can do what? What did we do before? I don't even remember now. Alright, so we don't actually want to call this test. We want this to be pack. So we want this to be pack as well. Alright, so let's try doing that. Syntax error. Oh yeah, yes, of course we need to do that. Alright, recursive. Gotta do that. Alright, Yes. Okay, so maybe that is a problem. What if we return something like that? That won't work. Yeah, I'm not sure this is gonna work. We might have to reconsider. Just might have to. So let's see, what else could we do? Alright, that's not right. Alright, let me, let's see. Whoops. I think it is this one. Yeah, so, and compressed T. Yeah, mess that up. Alright, whoops. Let's take a look at this. Ooh, that's interesting. So it looks like it just basically counts the elements. That's pretty cool, actually. So that's something similar to this. Yeah, well, I'm not gonna do that. So let's see. I'm trying to think about how we could do this. That's a problem, actually. Wait, how is this different? H equals first T, then compress T. So I don't understand why this one doesn't work, but this one does. Like, this should be doing the same thing as this, right? I'm understanding correctly. Let's go through it first. So there doesn't seem to be problems with that. Save function. T if h equals first t, then press t, else. Yes, that should be the same. This seems to be the only thing that is different. Unless I'm just completely missing something, but yeah, we need that actually. This is a problem actually. Ooh, okay. That could have been the whole problem actually. Yeah. Alright. So now they should function the same as that. Yeah, okay. Alright. So that was the little problem. So let's see if we can get this now. So if we do something like that, we wrap that like that. What does that do now? Yeah, so it just does that. So we need to put it into a list. Not quite there. Alright, well let's actually do this, because this I think might be required. So, alright, this person has type a list, a list. Okay. So let's see, how could we do this? Let's actually read about nested lists. Let's see. Let's have nested. Recursive. Yeah, so that's not the way to go, it looks like. So, do we need like a secondary one? I'm trying to think about how this should be solved. That's not let's see that next. It doesn't work. Okay. Alright, this person. Alright, this is 99 problems. Let's see. They have the. Alright, they go all the way to 14. So let's see. Pack. Yeah. So this has that aux keyword, which I don't quite know what it means. Let's pack. Yeah. Alright, so that's something beyond what I understand at this moment. So, yeah. So, let's just look through, duplicate the elements of a list. Would that be kind of easy? Let me think. I think maybe it would. Let me try that actually. So, yeah, this one also will be temporarily suspended, because I kind of need to just learn more before I can understand how to do it. It's just stuff in the language that I don't understand yet. So, yeah. Let me actually go back into that. Problem 9, I think? Yeah. So, temporarily suspended. There we go. Okay. Problem. Let's see. So, that was 9, 10, 11, whoops, 12, 13. Right, 14. Problem 14. So, skipping ahead a little. But let's see if we can do that. So duplicate equal function. If I can spell function. Alright, so if we do that, then we don't want to do anything. Whoops. And if it is that, then we just want to return that. I think that would work. Otherwise, then we want to return. We don't want to get stuck in a loop. Alright, I don't think we would. If we do something like head, as well as duplicate tail, something like that. I feel like that is pretty close. Alright. So this doesn't work, but can I just... Alright, let's see. Duplicate that. 1, 2. 1, 1, 2, 2. 3. 1, 1, 2, 2, 3, 3. Alright, 4. 5. 1, 1, 2, 2, 3, 3. Alright, so that seems to be right, actually. That was pretty simple. Let's look at the solution, actually. So, yeah, that's basically exactly what they wanted. Yeah, so I did it, well, mostly right. This, alright, yeah, I guess this one is kind of unnecessary. That makes sense. Alright, yeah, so if we do that, yeah, still works. Alright. Okay, that's pretty cool, actually. Pretty cool. Not too hard. Yeah. So let me actually exit out this. So git add dot git commit fashion added solution for problem 14. Duplicate the elements of our list. Skipped a couple which I did not yet understand. Alright, whoops. Okay. Yes, indeed. Okay. So let's try this one, and then I'll probably be done for the day. Problem 15. Whoops. .ml. Okay. So let replicate. This is going to be a list and an n number. Alright, so let's see. So if it is this, then we still want to return nothing. Otherwise, we do that. And then we might need another one. So let's see. So if we do something like let repeat, we just take a single element and the number, and this has got to be recursive. Then we can do something like, whoops, that's not right. Equal match element with, no, that's not what we want. So the element, if we pass it as a list, then we could return, let's see, I'm trying to think about how to do this. If n equals 0, then return element, else return, no, not return, then element, else we do repeat element, and then n minus 1. It's not quite right. Not quite what we want. Yeah, so we want to actually do like element that, something like that. And I think we want to wrap this in parentheses so it knows what we're talking about. So let's try that actually. So this we can just do that. Hello there, Hunter3397. How are you doing? Alright, let's do Utah. Use, not hello. Alright, syntax error. Yeah, so this actually needs to be match this with, there we go. Alright, still a syntax error. Oh, okay, actually, why is that? It's gonna be recursive. Ooh, we need to do that. Yeah, that's probably a good idea. Alright, yes, there we go. Alright. Expression has type A list, but an expression of type A. Alright, yeah, actually we want to make this a list like that. No, that's not what we want to do. Let's think about how to do this. I have a question. Alright, what is the question? N equals 0 should return that since it's the base case. That's okay, yeah. Well, yeah. Alright. Whoops. Alright, there we go. Alright, so there we go. Are you good at block coding? I'm not sure what block coding is. What do you mean by that exactly? You mean like Scratch kind of coding? Like where you drag the blocks in, or is it something else I'm not familiar with? Alright, yeah, well I haven't done too much of that in a while. Yeah. So I don't know. Like, it's basically just programming, just with I guess simpler to understand syntax, I suppose, but that not necessarily true. But same, I'm a coder too. Nice. Alright, so So that's not gonna work actually. Element. Yeah. Oops, I don't want that. I want, well, alright, yes, thank you for that. You have time to do a challenge that will take a week. Well, it depends on what it is. Alright, so let's actually test that and see if that works. So if we just give it that, whoops. Yeah, actually, so we have to do that. No. I want 2 times. Alright, yeah, so that's exactly what I wanted. So thank you for that. Appreciate that. Yeah, so we can do repeat h. Hit tail. HN. And it's just T, not tail. Alright, let me see what that does. Alright, so alright, so this is just so yeah, that's not actually gonna work because that's returning that. Not going. Yeah. Because we're yeah. I just realized that as I read your message. So, so I just gotta sort of rethink about this. So, yeah. So what's another way to go about doing this? Let's see. Yeah, that doesn't work. That appends to it, but where me and you will code a game, and in 1 week whoever wins gets nothing because I have nothing. I think I'm good on that right now, Hunter, but it does sound interesting. Yeah, you could concat, but you probably want to avoid doing that. Yeah. So I'm gonna have to think about a different way to go about doing this. Let's see. Repeat. So that's not gonna work. Alright, so this should do. Oh, it's not right still. Because of the way I have that. No, that's not what I want exactly. So how else would I want to go about doing this? Let's see. So we need to repeat it that number of times. I'm not sure how else we could do this. Let's see. Yeah, so that's the same as that one. Not quite. Oh yeah, so I didn't actually provide that there. That's kind of important to do. Yeah. Yeah, so that was that. So this basically just does nothing right now, I think. Yeah, so so that I think would work, right? Yeah, it's just not ideal. So what's a better way of doing that? Yeah, I'm not sure. Well, I mean, let's see, if we go back up here. Yeah, I don't know. I mean, that works. Not ideal, but yeah. Yeah, that's a good one. Yeah, I think that's good for now. I'll probably come back to it and make it better, but yeah, so I'll just commit that. Added temporary solution to problem 15, which is what? Which was replicate elements of a list n times. Alright, so I'll push that. Alright, there we go. And now it should be up there. There we go. Okay, yeah. So that's gonna be it for today. I'll do more learning off stream, figuring out more about how OCaml works, specifically looking into this kind of stuff, the awk stuff, because that's what I don't quite understand. That, and then this kind of thing, many one, all that stuff. Yeah. So yeah, I appreciate you watching, and I'll see you next time.